Rotem gave a very terrific talk about the broad perspective of quantum technology, and I do here, if you allow me, quite the opposite. So what I will do is I will present a very personal story on my career so far. And believe it or not, it started out on the Canary Islands, so in Spain actually. So I did a lot of my research was done in Spain between the Canary Islands, La Palma and Tenerife. We started in 2003. You know, these were the first experiments done outside the shielded laboratories. So people were questioning at that time if it is possible at all to leave the technology with this fragile new technology. And I have to admit that this was not my idea. I was a very young, and I have to say now, a very naive postdoc at that time at the Austrian Academy of Sciences and the University of Vienna at that time. And the European Space Agency actually, convinced us to go there and test. The reason is they have an optical ground station there, and they wanted to see if we can do on this long 144 kilometer long link a 30 dB downlink from a satellite. So this is comparable. That link between these two islands is comparable to a satellite. Later on, we really did these kind of experiments, not with a European satellite, but with a Chinese satellite. This is still the only one which is in space today. It's called Mitsu's experiment. I think to date we are still the only one who did these successful downlinks from an actual orbiting satellite to an Earth station. This time to Graz, which is very close to Vienna, as well as to Tenerife, again to Spain. So we did these experiments. So I can claim that we somehow contributed to the question that we can actually do those experiments outside the laboratory, and that really works. We did also experiments, you know, in the UK. In Bristol, here, also in Vienna, where we did a whole quantum network based on entangled photon source. Whatever that is, it's a mysterious thing that you have in the center of your network, which is that dot here, and you can distribute that to 8 different users, one after each other consecutively, and we published it in a quite high ranking laboratory journal. So we really did it outside the laboratory, and that it is something I'm proud of. And the next logical step in my career is not to pursue an academic research anymore. So actually I quitted my permanent position at the end of the year, last year, and I'm now a co-founder and 100% working in my company, which I'm proud to say I was able to fund with my former postdoc, Thomas Scheidel. So he is the CEO, he is now my boss here at the company. And we have extensive experience in doing research with many entities of research. So this is the Canary logo, and ICFO is here. So I've been there many times to do research with my colleagues there from academia, and now we are scaling up. So we hired quite a bunch of people. We have no investor. It's privately owned. What we do is actually scaling up a company which is now having a revenue of 2.4 million euros and 16 people. We have a laboratory here. We have 4 sites. We do research projects in parallel. We have a laboratory and an office here as I'm speaking. And what we actually do is we do feasibility studies. We do all the calculations to customers who want to understand what quantum is about, what that threat means to their business case, how much it costs to prevent, a quantum computer from hacking into their system in a couple of years. We do prototyping, and last but not least, and this is because historically we did free space experiments between 2 telescopes on the Canary Islands and also the downlink from a Chinese satellite. we are focusing on the space side of things more currently than fiber stuff. And this paperwork, this architectural paperwork is currently something which needs to be done urgently to protect the European industry. This is how the European politicians, how the decision makers in companies as well, also healthcare, military sector, banking sector, insurance sector, they all want to know what this is about. We also do research in the laboratory. So we actually do currently in a well-funded project by the European Space Agency, we build an entangled photon source. Again, the term entanglement, maybe we can discuss later in the public section what it is exactly. But it is a quantum source which is exactly doing what a quantum source will be doing on a satellite. So we need to produce these single photons in a very well-defined quantum state, and that needs to be competitive with the high loss you have from a satellite. We do all these calculations on the downlink. If it is a LEO satellite at 500-600 kilometer height, a GEO satellite. And by the way, very soon we will do a deep space communication on a single photon level, which is not quantum, but very, very comparable with that kind of things. So the first product, and this is what an architect wants, an architect draws a plan for a house, a blueprint for a house. So we plan these space missions together with the service provider, with the guy who builds the satellite and the ground and so on. We build building blocks of that. So one is the building block of building a source, which will be launched on a satellite. And of course, once you do a downlink to the ground station, you need a telescope, and we are actually building a telescope with a partner. So we partnered with a company who is experienced in building telescopes and domes. They originally did astronomical telescopes, but now we taught them how to do quantum receivers on ground, because this is what we did in our academic career before. And we see a huge business case. We believe that at least every capital city will be having several of them, and we will be selling them very soon with the name of QuantumSat. And this quantum revolution, I would like to say, will take place in the next couple of years. And I'm 100% convinced that there's a lot of ideas. Academia is moving on and feeding us and the new startups, the industry, with new ideas. So there will be a lot of ideas. There is a market. There is money available for investor. I will say a few words in a couple of seconds, and we will produce stuff, and we need people. People will be educated. People will be the obstacle in the future. So there will be a lot of jobs in the European industry in the coming years, being on the provider side, on the production side, as well on the customer side. So having that in mind, we funded not only one company, we funded several companies. We are a shareholder of Quantum Exponential, which is an investment fund, and we are funding actually startups. So if you have good ideas for us, if you have a vague business idea, if you are a young student finishing your PhD, starting your PhD, we are eager to talk to you. We provide you with means of talking to us, as investors, as well as to people who, private equity people who have a lot more money to scale up later. We do quantum consulting. As I said before, we talk to banks, and they are ready to pay a lot because they read about quantum computers everywhere in the public media. Quantum Technologies Laboratories QTLabs is the company which is maybe best known now in the media and myself. It is we see it as a R&D division of this holding, as we call it. QSS, Quantum Space Systems, we found just recently in Germany. We acquired a few key people there. People will be the important thing in the future, as has been already in the past, by the way, but not so well known. And that it is a problem, and we are looking for people. And Quantum Space Systems will be responsible to commercialize our space endeavors. And last but not least, we found in Austria that optical ground station support equipment company called Quantum SAT. So with that, I would like to conclude. I think I gave a rough overview, and I'm eager to talk to you, and let me know in the comment section or in the discussion later on if you want to know more about the new kind of industry popping up.